So, guys, welcome once again today, and thanks for joining early this evening. And yesterday, so we were discussing about normal distribution, right? So, we are taking normal distribution in great details. So, yesterday we are discussing about the normal distribution. So, this formula I want to tell you once again. Y is nothing x like x is nothing but what I am plotting on x-axis. Maybe age of the student or height or weight of a egg, whatever you say, experiment under experiment. So x is a variable. It's a data science variable, means it is containing multiple values. So x may have 20 entries, 35 entries, 40 entries, even 1000 entries, maybe 1 million entries. So x is representing a set of values. Okay. So x is what I am plotting on x-axis, and corresponding y I am getting from this formula. Let us study once more. 1 upon sigma root 2 pi, underroot root 2 pi. So underroot root 2 pi means it's a constant. Pi is a constant. Okay, we know that. So 2 pi underroot root 2 pi is a constant. Sigma is a variable. Sigma is nothing but your favorite standard deviation. X is nothing but your data science variable which is under study, for which we are studying the probability distribution. And mu is nothing but mean of x. Like x I said is a set of variables, set of values. So if I add up everything and divide by their total number, so that is mu. Nothing but the mean, average, whatever we call. So if I take average of x, that is nothing but mu. If I take sigma, standard deviation of x, that is nothing but sigma. So there are two variables apart from x here, sigma is and mu. Okay, so see x minus mu whole square divided by 2 sigma square. So formula looks complex, but if you look at it a couple of times, it will become familiar. So there are only two main variables here, mu and sigma. Mu is nothing but your mean, sigma is nothing but your standard deviation. Okay, so like depending upon value of mu and sigma, the curve, the normal distribution bell curve can take different shapes. Some bell curve for some mu and sigma, it can be very steep mountain. Some can be shallow mountain. Like that, number of. So now we are going to study this formula a bit in detail. So for you, I have written this formula on the top. You can see top the formula is written so that you do not don't forget it. So like depending on, as I said, depending on value of mu and sigma, there can be infinite number of normal distributions, right? Understand that, right? If I vary sigma and mu, and my curve will be different. So I can plot the infinite normal distribution curves. Is that understood? Be talkative in the class, yeah. If it is not understood, tell me.
Clear, sir.
Yes, sir.
If I vary value of sigma or mu or both, then I will get different value of y for x, same x, right? That means I can have an n number of or infinite number of normal distribution curves, right? It is understood. Now
Yes.
mean is denoted by mu and standard deviation by sigma. To understand that, a particular normal distribution is completely determined by mu and standard deviation of the. So if you want to define normal distribution, which is this formula, the two main variables are sigma and mu. So if you know sigma and mu, your normal distribution curve is completely known. Is that understood? Because we can put the value of sigma and mu, and then with the help of x, we can find the value of fx. Fx is nothing but your y. Is that agreed? Two main variables are sigma and mu. Is that agreed? And the normal distribution curve is completely defined if we know sigma and mu. Is it understood?
Yes, sir.
Like Jignesh and Karthik, is it understood?
Yes, sir.
Karthik, Amit,
Yes, sir.
as the value of sigma increases, like we discussed this previously also, like if I increase my standard deviation, my sigma, like my standard deviation will, the steepness will become less and less, less and less. The peak will be less sharper, right? If my standard deviation increases means my spread will increase. My spread increases means my curve will be shallow curve. It will not be steep curve. Got it?
Correct. Yeah.
Okay, so this is what the first. Then another same thing is like standard distribution curve. I want to show you like here. You can. I want to show you one curve. So this see here. Left of the mu is negative values and right of the mu are positive values. We agree with that? Positive values of x we are talking about.
Yes.
So to the left of mu, the values of x are negative. And to the right of the mu, values of x are positive, right?
Yes.
So now you see, for the negative values of x means to the left of mu, it is a ever increasing function. It is not decreasing, right? It's an increasing function, right? And for the right of the mu, it is a decreasing function. Is this understood? Then only bell curve will be formed, right? Left
Yes.
of the mu for negative values of x, it's a ever increasing function. And for right side of the mu, for positive values of x, it is a decreasing function. Okay. So like
Yes.
how we get this curve? So for every x, like if you know sigma and mu, for every x you will get the value of y and keep on plotting, you will get that bell curve, right? So that is one thing. Then as a result, the function is increasing function for all x that is less than mu. So for left of mu, which is negative values of x, the function is increasing, and function is decreasing for all x that is greater than mu. So right of the mu, right of the mu, we are getting a ever increasing function. Okay. Then the square root term which we have included here, root 2 pi, sigma root 2 pi. So that is to normalize the formula. Normalize means the value of y, if we don't give it root 2 pi, the value of y will increase more than 1. We don't want that, right? Because our probability is always less than 1. So we want to normalize this. Our value of this function fx should, for every x, it should lie between 0 and 1. That's why we give this root 2 pi value. Okay. Then like if, as I said, like if I calculate the total area under this curve, total area under the curve, both to the left of mu and to the right of mu. If I calculate the area of under the curve with this formula, which is normalized. So normalized means we are dividing by 2 pi. So total area will be 1. Left of the mu 0.5, area of the curve will be 0.5. Right of the mu, area of the curve will be 0.5. Is this understood? Total area will be 1 and 5 plus 0.5. Is this understood?
Yes, sir.
Very simple, right?
Yes.
Then we have so now you know that area under the curve is giving you probability. Okay, area of the under the curve is giving you probability. Okay. Now rather than using this formula to calculate the probability directly, like this formula looks very tedious, no? If every time or every x you have to use this formula means it may take a lot of time. So some kind mathematicians have already worked out values of fx. Fx means y. Y is equal to fx for every x. So they have plotted your tables. They have given us tables instead of applying this formula and calculating every time with the help of calculator. We can look at that table and find the value of probability. So we'll know we'll come to know how to do that. Okay, now these are the like broad characteristics or properties of this function. This function is but nothing but it represents normal distribution curve. Any difficulty till here? Anyone?
No.
Okay.
No, sir.
Even if you forget now, yesterday only I had shared this PPT with you. So once you go through this once again with a cool mind, you will always get reminded, okay? Because I am also teaching from this only. Nothing is from outside these PPTs. Okay. Now there is a new concept. So till now we were studying normal distribution. Normal distribution, which is given by y is equal to fx is equal to this right hand side formula. Okay. So that was a normal distribution. Now I am introducing a new concept which is called standard normal distribution. Standard normal distribution. So first we are studying normal distribution in general. Now we are studying standard normal distribution. So we studied like while studying normal distribution, we studied that we know mu and sigma. Mu means mean and sigma means standard deviation. If we know mean and standard deviation, your normal distribution is completely defined, right? Because this curve, two main variables are mu and sigma. If I know these two values, I can draw the curve. That means I can determine the curve. Okay. Now, what if I do one standardization? I keep mu as 0, in mean as 0. This mu value here in this curve. This mu value I keep as 0, and standard deviation I keep as 1. Mu I keep as 0. So to the right it will be positive values, and to the left it will be negative values. So mu will be 0, and standard deviation is 1. So how it is represented? It is represented in n mu sigma. So mu sigma means mu n 0 1. 0 means mu is 0 and standard deviation is 1. Then any normal distribution denotes a standard normal distribution. Suppose for any normal distribution, listen to me carefully. Suppose if for any normal distribution mu is 0 and standard deviation is 1, that means it becomes standard normal deviation. Okay. So standard normal deviation also some properties are there. The curve is perfectly symmetrical around mu, right? See, you can see the curve left hand side also same, and right hand side is the mirror image of that. So curve is perfectly symmetrical about mu. That is one thing. And for standard normal distribution, we know that mu is equal to 0. Meaning mean means mean and mu equal to 0. And standard deviation, which we denote by sigma, is 1. Is this understood? What is the difference between normal distribution and a standard normal distribution? Is this understood difference? Sarthak?
Yes, sir. A little bit, sir.
Yeah, so what is not understood, Sarthak? Tell me. I introduced a new concept on this slide that is called standard normal distribution. So if I know mu and sigma from this formula, which is there given on the top, which is given here, if I know sigma means standard deviation and mu means mean, I can completely draw this curve because in this because in this y is equal to fx is equal to this formula, there are only two main variables, which is mu and sigma. So if I know mu and sigma, I can draw the curve completely. Is this understood, Sarthak?
Yes, sir.
Now what I am defining a new concept here. If my standard distribution, my mu is 0, means mean is 0, and standard deviation sigma is 1, then I call it standard normal distribution. Is it understood?
Yes, sir.
Previously, I was talking about normal distribution. Now I am talking about standard normal distribution. So both are different. So standard normal distribution means my mu is 0 and sigma is 1. So if it is not a standard normal distribution, if it is a simple normal distribution means mu can be anything, and sigma also can be anything. But if I say mu is 0 and sigma is 1, then it is called standard normal distribution. Is this understood? Simple concept.
Yes, sir.
Okay, so now I'm introducing one more simple concept here, which is called Z-score. Z-score is a new concept. Just try to understand from the formula. Z is equal to X. X is nothing but your data science variable. So age, X, if I say X is age. So that may contain 20 child entry or 20 student entry. If I say X is height, it may contain 200 height of 200 people. If I say X is income, it may contain values of 1000 professionals. Understood what is X? Is this understood? X is a data science variable here. Is this understood? What is X?
Yes, sir.
Karthik, Amit,
Yes, sir.
Greg. Now X. At a time, I will take only one value from X. So X may contain, suppose 1000 entries. At a time, I will take only one value, say first value, Xi. Xi means X1 I will take. First value X1 I will take. I will deduct mu from it. What is mu?
Sir, mean.
Okay. X minus mu I did. Okay. So X1 minus mu first in that data science variable in which income is there, 1000 entries are there. I take the first entry, X1. Deduct the mean from there. First, I find out the mean. How I find out the mean? Suppose I have 1000 entries. I total up all 1000 of entries, 1000 incomes, and divided by 1000. So that's how I got mean. So that's how I got mean. So calculating mean or average, everybody knows. So now first entry I take X1 and deduct mu from, like mean from there. And then I divide it by standard deviation. So when I have values of 1000 entries of X income, suppose income of professionals, suppose I have 1000 entries, so I can find out mu, it is mean, and there are formulas, Sarthak, which I explained yesterday. How can you find out standard deviation? So by that formula, you can find out standard deviation. Okay.
Okay, sir.
So I will share the video with you. You can have a look. So I first find out mu and sigma. That is what I do first. I have 1000 entries, so I find out mean. And for that 1000 entries, I found out what is standard deviation sigma. That's what I do. Then for every entry, x1 minus, I do mean, x1 minus mean. See, mean and standard deviation for full column of 1000 variable will be only one entry, right? There will be only one mean and there will be only one standard deviation. Do you agree with that?
Yes, sir.
So I find out then x1. So x1 will be x will vary from x1 till x1000. X1 means first entry, x1000 means last entry. I take first entry x1, deduct mu from there, and divide it by sigma. Divide it by sigma. So that's what this particular mathematical fraction which comes, I call it Z. So I call it Z score. I call it Z score. Now you will ask, sir, what is the need of calculating this Z score? Why you have calculated this Z score? But is it, has everybody understood? Karthik and Jignesh, have you understood how to calculate Z score?
Yes, sir.
Now, there will be like how many Z score will be there? If suppose there are 1000 entries in a variable which is called income, there are 1000 entries. So how many Z score will be there?
1000 Cisco.
1000 will be there, right?
Yep.
Because for corresponding to each X, X1, X2, X3, like that, corresponding to each X entry, there will be one Z score. Now it is very clear. How many mu's will be there? In how many means will be there? For that
Only
column?
one.
How many standard deviations will be there?
Sir, only one.
Only one, right? So now you got, so with the help of, first I will calculate mu and sigma, and I will use them to find this Z score. Now be a little patient, and then we'll see why we have calculated this Z score. Now, see this green distribution, like we had a green distribution. So it is a normal distribution. It is not standard normal distribution. It is a normal distribution. Okay. Now, what is the mean of this green normal distribution? Tell me. Which is green in color, shaded in green. What is the mean of that? How much is the mean of this?
1010.
1010 is the mean, right? That peak value will be mean. How much is the median for this?
1010.
How much is the mode of this?
1010.
So yeah, you know that for standard standard distribution, for normal distribution, mean is equal to mode is equal to median. So it is which is equal to your peak value, right? Center value. Now what I do, I find out the Z score for this. I found, like I don't find Z score, I just instead of this particular green one, I convert it into standard normal distribution. Standard normal distribution means I plot only standard deviation, like +1 means one sigma away from 1 sigma away from 1 sigma away from mean, mu. Then 2 means 2 sigma away from the mean. Like mean is 0 here. So 3 means 3 sigma away from the mean. Now tell me one thing with this formula. What will be the Z score for middle value, mean value? What will be the Z score for Z value for mean value? Suppose I have 1000 entries. Mean can be anything, say 1010. So suppose 10 is 10 mean. What will be the value of Z for that?
0.
0, right? Because mean X is also 0 and mu is also 0. So open numerator will become 0, right? So it will be 0. So like if I say, so 0. So instead of 1010, I have plotted the Z value of that. So that is nothing but 1 Z value of that is nothing but 10. Then I take Z equal to 1. Z equal to 1 means which is 1 standard deviation away, 2 standard deviation away, 3 standard deviation away. Normally we don't go beyond Z is equal to 3. So Z equal to 1, 2, 3, if you plot, that is enough. Z is equal to -1, -2, -3, that is enough. Then why you will ask me question? Why you ask? Why you plot only? Why you take Z only till 3, not beyond 3? So I'll give you the answer. This we have studied a curve. I take you little back one, little back. Not here. Curve I showed you. Yeah, here. Now here also Z values are plotted. So for Z is equal to 0, it is center. Z is equal to +1, I have plotted. So +1 means it is 1 standard deviation away. So how many percent values are there between Z is equal to +1 and Z is equal to -1? How many percent values are lying?
95.
No. Z is equal to +1 till -1. See that -2 is written misprint on the left hand side.
Yeah, 68.
68%. Now Z is equal to 2 to Z is equal to -2. How many values are lying?
95.
55%.
Now Z is equal to 3 and Z is equal to -3. How many values are lying?
99.7.
99.7.
Now you understood why you go only up to Z is equal to 3? Because it covers most of the values. 99.7 means almost 100%, right? So
Yes.
if you cover Z is equal to 3 and -3, that means it will cover 99% of your range. Understood? So generally we need not go beyond Z is equal to +3 and Z is equal to -3. How many of you have heard that Six Sigma theory of these Japanese people? Six Sigma, like there is a quality control, no? Six Sigma quality control. So this Six Sigma quality control is based on this theory only. Standard normal distribution and normal distribution. So that is used, if you have not heard it, Six Sigma is a theory which is used in quality control in manufacturing.
Yes, Zuran's handbook on
Durance, yeah, Mr. Durance, yeah.
Zuran's.
So that is also all based on this standard normal distribution. But when people study the Six Sigma, nobody understands what is normal distribution. Now at least after this course, at least you will understand what is a normal distribution and why it is Six Sigma, why it is called Six Sigma. 3 on the right, 3 on the left, so total 6. And it is covering 99.7% of your values, X values. Okay. So that's why we generally don't go beyond Z is equal to +3 and -3. So now by this formula, we convert X into Z. We convert X into Z and then we plot different values. So we convert a normal distribution into a standard normal distribution. How? So instead of X, we plot Z. Is this understood? First, we had plotted C 110. See the green one, 1010, 1030, 1050, 1070. They are actual values of X. 990, 970, 950, they are actual values of X, which are there in a variable column, data science variable. So now that values we convert into Z value. How we convert Z value? X minus mu by sigma. And then instead of X, we plot Z values. then it becomes, so we convert a normal distribution into standard normal distribution. Is this understood? How to get a standard normal distribution?
Yes, sir.
Yes.
Understood, na? Simple, yeah. Simple. Just convert x value into z value. How? Just subtract the mean and divide by standard deviation. Because there are a lot of value. If we convert it into standard normal distribution, there are a lot of advantages. So maybe we'll see it later. Okay. So now you know how to convert a simple normal distribution into standard normal distribution. You got it? And note that the curve shape will not change. Curve shape will be exactly the same. The curve shape, whether you plot x on x-axis or whether you plot z on x-axis. So normal distribution is standard normal distribution. Curve shape will be exactly same. Right?
Yes, sir.
So now, like we have understood z feature. So a z feature, like any normal distribution, how you represent it? N. In the normal bracket, in the bracket mu comma sigma. Why mu comma sigma? Because mu and sigma are only variables in this dominant variables in this formula. Mu and sigma. So if I know mu and sigma, I know my curve completely. I can draw my curve completely. So it is normal distribution is always represented as n and mu sigma. So if it is standard normal distribution means mu will be equal to 0 and sigma will be equal to 1. Sigma is nothing but your standard deviation. Okay. So a normal distribution will represent by n in the bracket mu comma sigma. Mu can be any value, sigma can be any value. A normal distribution. But if it is a standard normal distribution, it will always be n 0 comma 1. Mu will be 0, mean will be 0, and standard deviation sigma will be 1. Is this understood?
Yes, sir.
Everybody? Now
Yes, sir.
Z-score, like Z-score if you calculate for X, so below mean there are some values, above mean there are some values. So if it is below mean, then Z-score will become negative. If X is less than mu, then Z will become negative. Do you agree with that? If X is less than mu, then Z will become negative. Do you agree with that? I'm telling X, suppose value of X is 8 and value of mu is value of X is 8 and value of mu is 10. So numerator will become 8 minus 10 minus 2 divided by sigma. Suppose sigma is 30. So minus 2 divided by 30. Will it not become negative value?
Yes.
Got it, na? So
Yes.
if X is less than mu, which is mean, your Z will become negative, and X is more than mu, Z will become positive, right? So now you will ask, what is the value range of Z? So Z varies from minus infinity to plus infinity. So it can be any number, right? So Z goes minus infinity till plus infinity. Okay. And minus infinity to plus infinity, and there is one property of this standard normal distribution curve. See, suppose if a green curve or blue curve, whatever you want to see, you see the end of the curve, like bell-shaped end of the curve, they will never meet x and x-axis. They will be parallel to x-axis, and they will go till infinity. Okay, so this bell-shaped curve, that shape ends will never meet x-axis. They will go parallel to x-axis, and they will go till infinity. So your z will be varying from minus infinity till plus infinity. Okay, are you okay here? So now we are going little one more concept, like there are z tables. So we will see how to read a z table. So you know what is a cumulative probability now. Okay, so this is a normal distribution curve. You see in the blue curve, bell curve. So we are familiar with it now. So now if I say the blue shaded region. So what does blue shaded region, the area which is shaded blue, what does it represent? Can anybody tell me what does it represent? The the shaded area blue, what does it represent? Anyone? Sarthak?
No, sir. Not sure.
Not sure. Anybody like Amit or Karthik or Jignesh? See, suppose Z value here, source, it is written Z right now, value is not given. Suppose it is equal to Z equal to, say, it is +1. It is plus sigma, plus right hand side plus sigma and left hand side. So it will show you the shaded area will give you the probability of Z less than equal to 1. Like Z equal to minus infinity to 1. It will give you the cumulative probability. We say na that suppose age is 1 year, 2 year, 3 year, 4 year and 5 year. So give me the probability of a child, like children less than equal to 3 years. We solve many problems, right? Less than equal to 3 years. So less than equal to 3 year means what? 1 year, 2 year and 3 year. Less than equal to 3 means what? So it will give a cumulative probability. Is this understood? What is cumulative probability?
Yes.
Yes, sir.
Less than equal to. Less than equal to. Suppose I have say 50 people I have taken from a random, like I went to city market and picked up 50 people, adult people, 50 I randomly pick up and measured their height. So suppose their height varies between 150 centimeter till 175 centimeter. So suppose minimum height which I get is 150 and maximum entry I get 175. And I arrange it in a increasing order. So my first entry will be 150 and last entry will be 175. In between, I have 48 more entries, right? Is this understood? Then if
Yes,
I
sir.
ask you, what is the probability, like if I pick up like in 50 people, I have asked them to like stand aside, like somewhere I asked them to stand. And I'm blindfolded now. I'm blindfolded. Just put a blindfold on my eyes, and I pick up. I just put my hand on somebody's head. Now I ask you a question. What is the probability of me getting a person with height less than equal to 160 centimeter? What was the maximum height? Tell me.
So 175 centimeters.
175 was the maximum. Minimum was 150. So what is the probability of me getting a height less than equal to 160 centimeter? I randomly selecting a person. Okay. So in such a question, we see this cumulative probability. See, there are two things. Exact question, if I ask, what is the probability of me getting a person of height exactly equal to 160? Exactly equal to 160 centimeter. And my second question is, what is the probability of me getting a person with height less than equal to 160 centimeter? Both the questions are different or not?
Yes.
Yes, sir.
In one first case, I want to find out a person with height exactly equal to 160. And in second case, I want to find a person less than equal to 160. Which probability will be more?
Sir, less than 160.
Less than or equal to.
Less than or equal to, right? Because in there will be so many people with less than equal to 160. Okay. So probability will be more. And suppose I want to find only 160. It may be there that 160, there is only 1%, the probability will be less only, right? So less than equal to, if I say what is the probability of me getting a person less than equal to 160, so that will be more than, that will be more, right? So such a probability, suppose if I convert that 160 height, 160 centimeter height into Z value. So to the left of that will it not be cumulative probability? Like, suppose if I convert, I told you can convert 160 like into Z value. Like how you can convert with this formula, right? 160 minus mean divided by standard deviation. You got Z value. Now suppose you have this Z value you have plotted here. And I'm asking the value, I'm asking a question, what is my probability of getting? What is my probability of getting a person less than equal to 160? So is it not covering Z from minus infinity till 160?
Yes, sir.
Is it not covering all the person from 150 till 160? So area on the left, shaded area on the left, is that probability? That's what you are looking for. Shaded area on the left is the probability. That's what you are looking for. That I want a probability of finding a person less than equal to 160. So that is what is your shaded area. So between 150 and 160, what is the probability of finding that person? So that is the shaded area. Now you got what is cumulative probability.
Yes, sir.
Now if I ask you a question, simple question, what is the question? What is the probability of me getting a person more than or equal to? Like more than greater than or equal to 160. What is the probability?
Sir, 1 minus cumulative probability.
1 minus cumulative means the area which is not shaded, which is shaded in white, that will be that probability. Correct or not?
Yes, sir.
Yes,
The
sir.
total area on the curve is 1. So if I left hand side, if it is representing less than equal to 160, right hand side will represent greater than equal to 160. Right? 1 minus less than equal to 160. Right? So now you understand cumulative probability.
Yes, sir.
This area under the curve represents the cumulative probability. That is what is the very, very important probability, important property of a normal distribution. Or in fact, any probability distribution you draw, area under the curve will be the cumulative probability. Any distribution, any shape. Now we are talking about normal, so it is perfectly bell curve. But if you draw any shape of curve, so area under the curve will give you cumulative probability. Is this understood now?
Yes, sir.
Yes, sir.
Now, some gentlemen, statistics people, mathematicians, they have converted this into tables. So how to do now? See, I find like first of all, we have two type of Z values. First, on the right hand side of the mu, which are positive, and second type of Z values are left hand side of the mu, which are negative. Is this understood? Left hand of the side will be negative Z values, and right side will be positive Z values. Is this understood?
Yes, sir.
Understood, na? Like everybody, Amit,
Yes.
Karthik,
Yes, yes,
not
sir.
you just ask the question. So you have two type of Z values.
Yeah,
Right of the mu is 0 only. So right of the mu, positive Z values, left of the mu, negative Z values. So there are two type of Z tables available. One is your positive type of Z values, positive Z table and negative Z table. First, we are talking about positive Z values. Okay. So you see on the first column here, 0.1, 0.2, 0.3, 0.4. Can you notice that? 0.1, 0.2, 0.3, 0.9, 1.1, 1.2. Can you notice that column?
Yes, sir.
So that is what is your Z value. Right hand side. Starting from 0. 0 means mean. 0 means mean. And starting on the right hand side. And what is that point? 0.00, 0.01 on the top? You can see row, top row. 0.00, 0.01, 0.02, 0.03, 0.04. What is it? Can anybody guess what is it?
So standard deviation.
No, it is also Z. Suppose I want to find out 0.54. Z equal to, suppose Z value is 0.54. So can you read from this table now? See, 0.5 Z equal to 0.5 I can read, look it from here.
0.6 points. Sorry, 0.
I want to take this call.
Okay.
Important call for me. Give me a minute.
Yes, sir.
Hey, sorry guys, yeah. So see now I have Z value, I calculated Z. See Z0 means perfect that top peak line. That top line is peak line is Z equal to 0. Now I converted one X value into Z value. I got Z equal to 0.54. So can you read from here? Corresponding to Z is equal to 0.54, I want the cumulative probability. So in the inside the table, whatever value you are getting, inside the table, these are cumulative probability. So I want now the value corresponding to Z is equal to 0.54. Can you read from here?
Sir,
See, I'll tell you. Tell me, anybody wants to attend?
sir, 0.7054.
No. 0. Yes,
7054.
very nice, very nice. See, 0.5 I will read from here. 0.5 I'll read from here and then I'll go horizontally till 0.04. You can see 0.04, right, on the top in the column. So 0.54 now I got 0.5 here and 0.5 from the column, a row. So that value will be 0.7054. So like he has read correctly. Now I'll take you to see here. Now here I am reading that value. Now it's very clear now here. So how we will read 0.054? 0.5 from the vertical column, 0.5 from the vertical column and 0.4 from the horizontal row. Now you got this. You can see now that yellow boxes. And that is how I will see the value of cumulative probability is 0.7054. How you got it? Everybody?
Yes, sir.
Now tell me what will be the value of 0.74? Tell me. What will be the value of 0.74?
0.7704.
Wow. So you got now Karthik and Jignesh how to read it?
Yes, yes, sir.
Now you tell me last one. What will be the value of Z is equal to 0.17? If I get Z equal Z value, if I got 0.17, what will be the cumulative probability?
0.8577.
No, 0.17 I am asking.
Okay. 0.17.
0.17.
Yeah, 0.5675.
Great. So now everybody got how to read Z table?
Yes, sir.
Got it, na? Karthik,
Yes, sir. Yes, sir.
Jignesh,
Yes, sir.
you got it. Now how to read a Z table? So these values on the like which is there on the left of your column and top row, they are representing Z values. And whatever is there inside the table, they are your cumulative probability. So now if your Z value is coming 0.54, you know the cumulative probability is 0.7054. Got it?
Yes, sir.
How easy it is? So these Z table are always allowed in the exams or any calculations or anything. The Z tables are normally, it's a standard allowed in exam and they give you, if anybody is asking you numericals on that, they will give you Z table. Understood? Na? Now, this was positive Z table. This was positive Z table. You see, positive. Positive means to the right hand side of the mean. So it will cover right from minus infinity till that mean value. After that, till that Z value, it will cover cumulative probability. Similarly, Z tables are available for negative values also. So negative value means it will cover only left hand side area. Now tell me, reading is similar. Reading is similar. Can you tell me what will be the, I want to read. My Z, see, I calculate Z. My X is less than mu. So Z will come negative, right? So now read me, suppose if I get, suppose if I get Z is equal to 1.9392. If I get Z is equal to minus 1.92, what will be my probability value? Z equal to minus 1.92.
0.0274.
74.
0.0274. Now remember one thing. If my Z is negative, my cumulative probability will be always less than 0.5. Is this understood? See,
Yes,
middle
sir.
line, mu line is 0.5. So suppose my Z is negative means I am less than 0.5, right?
Yes, sir.
Yes,
And
sir.
if my Z is positive, my mu, my cumulative probability will always be more than 0.5. Is this understood?
Yes, sir.
Understood, na? So now you know, so you have positive Z table, you have negative Z table. You know how to read it. Now tell me one thing. Next thing I want to ask you here. This is the question. Now this is the question. You see this curve? Now I want the probability. What probability I want to calculate? More than A, greater than equal to A, but less than equal to B. How you will calculate that? Both Z are positive. See, it is on the right hand side of the mean, right? So my Z is positive for both A and B. So now I want cumulative probability of the shaded area, which is more than equal to A and less than equal to B. Can you find out? Shaded area, blue shaded area. Can you find out how to find out?
Sir, we'll calculate less than equal to A and more than equal to B and subtract it from 1.
No. You are making a little mistake. I think you know it, but you are not spelling it properly. Little think and tell. You are on the right path, but you are not able to define it properly.
So
Tell me.
we'll calculate the white area and subtract it from 1.
No?
So we'll calculate less than A, then less than B,
Yes.
then B minus.
Less than B minus less than A will be your blue area. Got it? Got it?
Yes,
Nah?
sir. Yes, sir. Yes, sir. Yes, sir.
So first I will see what is my probability Z equal to A, Z equal to less than equal to A. That's what I'll get some region, some probability. Then I'll calculate what is the probability of cumulative probability for Z less than equal to B. I got both. Now I get the Y bound A between A and B. So I'll subtract whatever I got for B from A. Got it, na?
Yes, sir.
So can you not solve probability problem with the help of this? You can solve probability problem, right?
Yes, sir.
Huh? So you can solve now. So we'll solve some probability problem. Now let us. What is the time? What time we started?
6 we have started.
Okay, so a couple of probability examples we'll take. So one example is there. Read on the left hand side. What is written in the white? For some computers, time period between charges of the battery is normally distributed with a mean of, means where some computers are there and battery operated computers are there, and we are charging the battery. So what is the battery life? Like if once I charge it, how much time it takes to discharge completely? So that is what we are measuring. So he's telling they are normally distributed. So that is normally distributed. And the mean is 40. Mean is given 50. And standard deviation also he has given 15. Mean is also given. It is first of all, it is giving that it is normally distributed. Then he is giving mean as 50, mu equal to 50 and sigma equal to 15. Rohan has one of these computers and needs to know the probability that the time period will be between 60 and 70 hours. Means Rohan is a guy who is having same computer and he wants to know what is the probability of his battery lasting between 50 and 70 hours. So that's what he wants to find out. Means this problem, right? A equal to 50, 50 and 70, na? A equal to 50, B equal to 70. What is the mean? Mean is 50. What is standard deviation? 15. Okay, so now let us see the solution on the right hand side. Okay, so mu is given 50. So it is written given mu is equal to 50. Mean is 50. Given standard deviation equal to 50. That's what we get. Probability of x varying between x means our data science variable, random variable varying between 50 and 70. So that is given by P in the bracket 50 less than x less than 70. That is the representation, right? Now we calculate Z value first of all. First of all, For a equal to 50 and a equal to 70, we calculate the z value. See how it is calculated. For x is equal to 50 means lower limit z is equal to 50 minus 50 divided by 15 is equal to 0. It is mean only, na? Yeah. Mean, so for mean z value is 0. For x is equal to 70, z is equal to x minus mu. X minus mu means 70 minus 50 divided by 15. 15 is your standard deviation. It is given. It is 1.33. So now you have to find out the probability between x is equal to 0, like z is equal to 0 and z is equal to 1.33. See, it is given. So you have to find out probability between z is equal to 0 and z equal to 1.33. So now you find area to the left. See, so z is positive, right? Both the z's are positive. 0 also positive, 1.33 also positive. So you find, so 1 point from 1.33. So let us see, we have that z table. No, yeah, we do see the one positive z table will go below this. So that z table we don't have. So suppose you find out, you know how to read 1.33, right? So you find out the area to the left, that is coming at 0.982, 9082. Area to the left of z is equal to 0. So again you find z table and you are getting 0.5. You subtract it, the probability is 0.4082. Is this problem understood or not?
Yes, sir.
Everybody, Signesh, Karthik, Amit, Sarthak.
Yes, sir. Yes,
Yes,
sir.
sir.
Now you are calculating this normal distribution to solve useful problems, right? This guy wants to know the probability that my battery will last between 50 and 70 hours. That is a practical problem that guy has. So we have done, we solved it for him, right or not? Okay. So let us take couple of more examples. So, first of all, is this understood? Like Amit, is this understood?
Yes,
Yes,
sir.
sir.
Understood, na? See, I
Sir.
don't have Z table for 1.2, and so if you search the internet, Z table for normal distribution, you will get Z tables for free. On the internet also you will get. From there you can find what is the, for that Z, what is the cumulative probability. So it is coming 0.9082. Then for Z is equal to 0, what is the cumulative probability? That is coming 0.5. Yeah, it will be, you need not read also. At the mean Z is equal to 0, cumulative probability will always be equal to 0.5. Correct, no?
Yes, yes.
So Z minus 0.9082 minus 0.5, answer is 0.4082. Nice. We are doing a, we are using the now these Z tables and Z value to solve useful problems. Right? So now next problem. Speeds of car, we are measuring speeds of cars. Measured using a radar unit, we are measuring speeds of the car using a radar. The speeds are normally distributed. Like speeds of the car is measuring speeds of n number of cars and then is plotting it. So they are normal distributed. Mean is given 90 km per hour and standard deviation is given 10 km per hour. So mu also given, sigma also given. Done. What is the probability that a car selected at chance, like at random any car that police guy is selecting, is moving more than 100 km per hour? See, maybe that country, maybe US or somewhere, in India, the road speed limit is 75. And many places, these police people will stand. And if you are moving, they will measure with the help of radar. If you are moving, you are found to move more than 75 kilometers per hour, they will fine you. So maybe in some country like UK or US and some other developed country, instead of 75 kilometers per hour, that limit is 100 kilometers per hour. Now the question asked is, I have given you mu equal to 90 and sigma equal to 10. Now I am selecting a car at random. So what is the probability of it moving more than, means what is the probability of moving more than 100 kilometers per hour? So see again, you find Z convert 100 and 100 and like why 100? Mu equal to 90. Okay, mu equal to 90 and standard deviation equal to 10. Okay, so our X is 100. X is 100. X is 100. Okay, X is 100. So Z value is 10 minus 10 means your X, 100 means X, minus mu. Mu is 90 divided by 10. 10 is standard deviation. We got z equal to 1. So now z equal to 1. So now in this we have to find out the area of the curve towards right of the curve or towards the left of the curve.
Sir, right of.
Right of the curve, right? Because we want more than 100 kilometers. So we want the right area. So what is the right area? First we find out from the first we find out total area. So total area on the curve is 1. 1 minus, you find z equal to 1. So z equal to 1, what is cumulative probability? So easy. You find out from z table that for z equal to 1, cumulative probability is 0.8413. So 1 minus 0.8413 is you got 0.1587. So there is a 15.87% chance that this any person randomly selected car will be fine because he is moving more than 100 kilometers. Okay. So we solved this problem also. Anybody and anybody, Jignesh? Anybody? Everybody understood? Karthik?
Yes, sir. Yes, sir.
Amit understood problem?
Yes, yes, sir.
Now, this problem I want you to see yourself. Okay, so now this also will solve and we'll close for today. A new tax law, listen carefully, a new tax law is expected to benefit middle income families. Means Modi has made some tax law and Modi is telling that it will benefit, it is for the benefit of middle income family, means people like us. Those with income between $20,000 and $30,000 per year. See, $20,000 and $30,000 per year is a very less salary in US. Very difficult to survive for a family. So if you want to survive in US, means your dollar salary should be more than 50 or 60,000 per year. Dollar 50 or 60,000. Then only you can barely survive. So 20,000 and 30,000 salary if you have per year, that means you are kind of in lower middle class or poor class family. So this law will benefit between whose income is 20,000 and 30,000. So lower middle class, it will benefit in US. If family income, now it is giving normal distribution. So I said you normal distribution. The normal distribution is always represented by, I showed you here, how normal distribution is represented. N, see the first bullet. So you have to show normal distribution means N in the bracket mu comma sigma. Mu is mean and sigma is standard deviation. So he is giving us normal distribution here. So normal distribution is representing in a professional way. So normal distribution mu is 25,000 and sigma is 10,000. That's how you have to read it. N 25,000 comma 10,000 means mu is 25,000 and sigma is 10,000. Okay. Ignore that square. Don't worry that square is, I think it's a mistake. So mu is 25,000 and sigma is 10,000. Is it understood? Everybody?
Yes, sir.
Yes, sir.
Yes.
What percentage of the population will benefit from the law? What percentage of the population benefit the law? Means you have X lower limit is 20, higher limit is 30. So you have to find out that middle one. See here, this particular thing. A is equal to 20,000 and B equal to 30,000. So middle area you have to find. So that's what is very simple. Now X is the family income. And what to find? See, X between 20,000 and 30. So solve let Z like first for lower limit we are finding what is X. So like if you subtract X is lower limit is 25,000. So 25,000 is Z equal to 0. Or 25,000 Z will be equal to no. So 25,000 minus 20,000 minus 25,000 means X is less than mu. Mu is 25,000 and X is 20,000. So 20,000 minus 20,000 divided by 10,000. Now you got it. So it is coming as minus 0.5. 20,000 minus 25,000. It is coming as divided by 10,000 is coming as minus 0.5. Have you got it?
Yes, sir.
Now for 30,000 we are calculating. Now it is more than So keep 30,000 minus 20,000 divided by 10,000. So we are getting Z equal to 0.5. So now we have to find out the area between the curve where Z is minus 0.5 and Z is 0.5. So lower limit is minus 0.5, upper limit is Z equal to 0.5. Okay. So in that we have to find out the area. So if you see the negative Z table, so negative Z table, if you see like first for 0.5, if you see like I'm not sure how he is calculated, but you have to first see cumulative probability for 0.5 and then you have to see for minus 0.5 and see the area between them. So now I'm not sure how he has done this calculation and like how he got 1.383 and minus 1. So this a little bit of confusion here. Here's some roundabout way he is calculated. See.
So it's 2 factorial 5 or like that?
No, it is not factorial. Like see, 0.5 on the left and 0.5 on the right. So it is effectively 2 into 0.5, right? Understood? What it is he has done. 0.5 is on the left of mu and 0.5 on the right of mu. Okay, so it is effectively 2 into 0.5. Done, no? Okay, you don't do it this way, you forget this way of calculating. You like we'll see like what is the value. Let us try to see our so note down here, note down. Mu equal to like if it is positive. So for Z equal to 0.5, we are getting 0.6915. Note down. 0.6915. Z value. You got it now? 0.5. 0.5 and 0. So 0.50 we are getting cumulative probability as 0.6915. Got it? Understood now? Why we got 0.6915?
Yes, sir.
Now let us see what is the value for 95. And minus 0.5. So minus, suppose we have okay, unfortunately we don't have the table available for minus. Minus we'll see now. Let us where to see the internet only. So wait. I'll stop share for a second. And then
Sir, it's 0.3085.
point for minus 5, how much?
So it's 0.3085.
Then you minus no minus 6.63, 0.69 minus 0.38. How much it is come? So you saw from internet table, right?
Yes, sir.
Yeah. So you just subtract now 0.69 minus 0.68. You got the answer. How much you are getting? 0.383.
Yes, sir.
So now that's what is the answer here. Then why you want to depend on him? Whatever way he has done, let us forget it. We do the simple way. You find out the cumulative probability for Z equal to 0.5 and you find the cumulative probability for Z equal to minus 0.5. Subtract 0.5 cumulative probability from minus 0.5 probability. So you are getting the answer 0.383, right?
Yes, sir.
Whatever is here, the way he has done, we need not, don't let us ignore. We'll do our way. For Z equal to 0.5, the cumulative probability is 0.69. For Z is equal to minus 0.5, the cumulative probability is approximately 0.38, right? So 0.69 minus 0.38, approximately we are getting answer as 0.383. We got the answer here. Okay. So that's how we are using Z table. We are using normal distribution. We are using how to calculate solving useful problems. We have done that. 3 useful problems we solved and all are practical problems, real life problems. So now next is student key distribution. So another type of distribution, little bit twist of normal distribution. So when you have number of samples, more than 30, I said you will use a normal distribution. And suppose you have a number of samples less than 30, 30 or less than 30, then you will go for student T distribution. So what is it? I think it's a topic for tomorrow's lecture. So after student T, we have one more. Student T is there. Then we have uniform distribution. So after that you have uniform distribution. There is so two more distributions are there. Student T distribution and uniform. So uniform, as you can see, is very simple. It's a simple straight line. Probability is constant between A and B. So your probability lower limit A, upper limit B, probability is constant between them. So like tossing a coin. Tossing a coin, probability is always 0.5, right? Success, failure, both probabilities are equal. So like that is uniform distribution. So that there are two more distributions we'll study. Sorry, one is student T and one is uniform.